Hi, it's Amy with Behind the Tweet. Today, I want to talk about a consideration that I think is important when it comes to pathogens or pathobions and chronic inflammatory disease. Many people are open to the fact that pathogens may drive a chronic infectious condition. If they do, pathogens often drive chronic inflammatory disease by dysregulating a human pathway. For example, pathogens can act on a human receptor or a human pathway and dysregulate activity of the pathway so that the human body, is actually no longer functioning correctly. So they're big drivers of disease in that fashion. Now, however, right now, when we try to tie a pathogen to a chronic infectious condition, we assume that if a pathway is dysregulated by a pathogen, all patients with the condition should probably test positive for that pathogen. So we'll do some testing and we'll search for possible pathogens in patients, and we'll see if those pathogens can indeed dysregulate a human pathway. But if we don't find that pathogen in most patients with the condition, we'll tend to say, no, I don't think it can be a driver of that dysregulation. Consider this. There's great redundancy in how pathogens have learned to survive, dysregulate the host immune response, and dysregulate host gene expression and metabolic pathways. So I'm going to use an example. Let's say there was a condition in which mitochondria were affected. Let's say mitochondrial metabolism was dysregulated, and we found that a viral pathogen could dysregulate mitochondrial metabolism in a way that resulted in a disease process. Now, we would look at the literature and we could say, yeah, that could be the case, because there's a great body of literature which actually shows that viruses can infect and disable mitochondrial metabolism. Not always in the exact same way. So this is a little bit of a theoretical example, but you follow me, right? So we know, even today, that a number of viruses like Epstein-Barr virus or the hepatitis viruses can infect mitochondria and disable how they function and work. But there are also studies which show that a number of bacterial pathogens can disable mitochondria and disable how they're able to function and work. And I even looked, and there's some studies which show that different fungi or even parasites can infect mitochondria and disable how they function and work. What that means is if we found that there was a consistent way that these pathogens were acting on mitochondria, a patient with that dysregulated pathway, if it was infected, would not necessarily have to harbor the same pathogen or pathogens as other people who suffered from the same thing. So one patient might have a viral infection that drove that mitochondrial dysregulation. Another patient might have a bacterial infection that was driving that mitochondrial dysregulation. And a number of people could have a fungal infection that was driving the same dysregulation. What that means then is that patients with a chronic condition tied to dysregulation of pathways by microbes may not have to test positive for the same pathogens, groups of pathogens at all, right? And what I think really adds to that point is that a lot of microbes in the human body have yet to be discovered. So we haven't even discovered all the bacteria that likely persist in the human body, let alone where they're persisting. There's probably a lot more bacteria, in my opinion, from early studies in tissue and blood than we're accounting for. Also, viruses are just really fascinating. People lately have been studying the human virome. And the human virome is the population or ecosystems of viruses that persist in the human body. And these populations have proven to be vastly more extensive than we previously thought. So basically, the current estimate is that there are maybe up to 30 billion viruses in a human body, a person's tissue and blood at any one time. And to be fair, a lot of these viruses are bacteriophages, or viruses that infect bacteria. So it's a certain type of virus that dominates these viral populations, but still, those viruses have a tremendous impact on how the microbiome functions and on the dynamics of how the ecosystem functions. I mean, they infect bacteria, so they're going to modulate bacterial activity. Okay, so going back to my point, we have, first of all, yet to discover many of the microbes and viruses that persist in the human body. Then on top of that, even the ones that we have identified, we have yet to study. We really haven't studied that many human microbes, because you'll see that, for example, I tend in these talks or in my articles to use Epstein-Barr virus often. And that's because Epstein-Barr virus is actually connected to a great number of inflammatory conditions. But also, Epstein-Barr virus has been well studied. There are a number of research teams who've looked at Epstein-Barr virus and tried to characterize how it infects cells, what cells it can infect, what it can do when it infects cells, if it can modulate human pathway activity, things like that. So I can better talk about Epstein-Barr virus because of that. But there are many microbes in the human body that may be acting very similarly to these better studied and characterized microbes that may also do the same things as them. To go back then to my original analogy, you could have in a condition driven by mitochondrial dysfunction tied to infection, you could have viruses that we know, like Epstein-Barr virus, that infect and dysregulate mitochondria. You could have bacterial species that we know, like Mycobacterium tuberculosis, infect and disable mitochondria. You could have fungi that we have characterized, infect and disable mitochondria. But in certain patients, we might not even have yet identified or characterized the pathogens that may be infecting and disabling their mitochondria. So on a blood test or even on a scientific, more professional scientific level analysis, that patient might not even test positive, or there might not be indications of the pathogens that may be driving these disease processes in some of these patients. So what this means is there are following couple takeaway points. We may not always find the same pathogen in patients with the same condition. Different pathogens can drive similar dysfunction in people. They can dysregulate the immune system and human pathways in similar ways. So different pathogens may be able to drive a common disease outcome. And we need to take that into consideration when we're searching and looking for microbes as drivers of disease and infection. We cannot throw out data simply because every patient with a chronic condition doesn't test positive for the same infectious agent. All right, that's my thought for today. Talk soon.